Good day, this is Laboratory 2 for Data Communication. First, what is the OSI model? The OSI model is a seven-layer reference model for describing the functions of a communication system. It is divided into seven layers, each layer serving a different purpose. In the transfer of data, the layers are from top to bottom. First is the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. First, what is physical layer? This layer is responsible for transmitting raw bits over a physical medium. It is responsible for the actual physical connection between the devices by identifying the equipment involved in the data transfer. Layer 1 defines as the hardware equipment, cabling, wiring, frequencies, and pulses. Example of these physical devices are cables and network interface cards. Second is the data link. The data link provides the functional and procedural means to transfer data between network entities. It detects and possibly correct errors that may occur in physical layer. Its major role is to ensure error-free transmission of information. This layer is responsible for delivering data in a form that can be understood by the physical layer. For example of these devices are Ethernet adapter and network switches. Next layer is the network layer. The network layer is a part of the internet communication process where these communications occur by sending packets of data back and forth between different networks. This is this layer is responsible for routing data through the network. The devices are routers and switches. Next, we have transport layer. This layer provides transparent transfer of data between end users, providing reliable data transfer services to the upper layers. The transport layer controls the reliability of the given link through flow control, segmentation and desegmentation, and error control. Also, this layer is responsible for reliable end-to-end delivery of data. Example of these devices are the TCP/IP protocol software or the Transmission Control Protocol Internet Protocol and the UDP or User Datagram Protocol software. Next, we have session layer. This layer is responsible for establishing, maintaining, and terminating communication sessions between two devices. Example of these devices are virtual private network or VPN clients. A VPN client is a software-based technology that establishes a secure connection between users and VPN server. Some VPN clients work in the background automatically, while others have front-end interfaces that allows users to interact with and configure them. Next layer is the presentation layer. The presentation layer is the lowest layer in which applications programmers consider data structure and presentation instead of simply sending data in the form of datagrams or packets between hosts. This layer is responsible for data formatting and encryption. Example of these devices in this layer includes conversation programs and image manipulation programs. Next, application layer. This layer provides the interface between the user and applications. It is the lowest layer of which application programmers consider data structure and presentation instead of data sending in a form of datagrams or packets between hosts. Example of these devices is web browser, FTP clients, and email programs. Next, let's go to network devices. The network devices should be discussed are repeater, hub, switch, router, firewall, wireless access point, network bridge, network interface card, and gateway. First, the repeater. In telecommunication, a repeater is an electronic device that receives a signal and transmits it. A repeater is used to extend the range of the network by amplifying the regenerating the signal. Second one is hub. A network hub is a node that broadcasts data to every computer or Ethernet-based device connected to it. A hub is less sophisticated than a switch. The latter of which can isolate data transmission to specific devices. A hub is a basic networking device that connects multiple computers together with a local area network or the LAN. Next, we have switch. A switch is a networking device that can connect multiple devices together and manage the flow of data between them. A network switch connects devices in a network to each other, enabling them to talk by exchanging data packets. Switches can be a hardware devices that manage physical networks or software-based virtual devices. Switches form the vast majority of network devices in a modern data networks. Next, we have routers. A router is a networking device that connects two or more networks together by routing data packets between them. The firewall. A firewall is a networking device used to protect a network from unauthorized access. A firewall is a network security device that monitors and filters incoming and outgoing network traffic based on the organization's previously established security policies. Wireless Access Point or WAP. Wireless access point is a network device that allows wireless devices to connect to wired networks. An access point is a device that creates a wireless local area network or WLAN, usually in office or large building. An access point connects to a wired router, switch, or have via Ethernet cable and projects a Wi-Fi signal to the designated area. The network bridge. A network bridge is a device that connects two separate network segments together. The mechanism of network aggregation is known as bridging. The bridge is a physical or hardware device but operates at the OSI model's data link layer and is also known as the layer of two switches. The network interface card. A network interface card or NIC is a device installed in the computer that allows it to connect to a network. A NIC provides a computer with a dedicated full-time connection to a network. It implements the physical layer circuitry necessary for for communicating with a data link layer standard, such as Ethernet or Wi-Fi. Each card represents a device and can be prepared to transmit and control the flow of the data on the network. Next is the gateway. A gateway is a networking device that connects two separate networks and acts as an intermediary between them. A gateway device provides communication to a remote network or an autonomous system that is out of bounds for the host network nodes. Gateways serve as entry and exit points of a network. All data routed inward or outward must first pass through end communication I, and communicate with the gateway in order to use the routing path. Next, let's go to network cables. Network cables includes coaxial cables, shielded twisted pair or STP cables, fiber optic cable, unshielded twisted pair or UTP cable. Coaxial cable. Coaxial cable are used to transmit data signal over long distance, such as between two buildings. They are commonly used for cable television and internet connection. Coaxial cables are shielded from electromagnetic interference, which make them ideal for this type of applications. Shielded twisted pair or STP is used to connect computers and other devices within a network. They are also used to connect computers to modems and routers. STP cables are shielded with electromagnetic interface and is therefore more reliable than UTP cables. The fiber optic cable. Fiber optic cables are used to transmit data over long distance. They are commonly used for internet connections as well as for communication between buildings. Fiber optic cables are made to thin strands or of glass and are immune to electromagnetic interference. The unshielded twisted pair or UTP cable. These cables are used to connect computers and other devices within a network. They are also used to connect computers to modems and routers. UTP cables are not shielded from electromagnetic interference and are therefore less reliable than STP cables. That's all. Thank you. Have a great day.